Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is reordered power of 2. Now, the problem category is of medium level, but I think it's a very easy problem to solve. Let's start reading the problem, understanding the problem, and then we are going to solve it, understanding the intuition as well. Now, you are given an integer n, so we are given integer n as an input. We reorder the digits in any order, including the original order, such that the leading digit is not a 0. We need to return true if and only if we can do this, so that the resulting number is a power of 2. Alright, so I will tell you what they basically wants in the particular problem. So we have a given input n, right? This is given to us as an integer. What we can do is we can reorder the digits in the input n. We can do this particular operation. We need to do this operation in such a way that we are able to convert this n into an exact power of 2. When we say power of 2, we mean that 2 is to power 0, which is 1, then 2 is to power 1, which is 2, then 4, then 8, then 16, then 32. This will continue, right? Basically, all the numbers which are power of 2, and when we say power of 2, they should be exact power of 2. The powers should be integer. So we need to rearrange this number n, and we need to make sure that while rearranging, or I would say while reordering, there should not be any leading 0. I mean, if your number n has a 0, you cannot put that 0 in front or as a leading number, and that basically eliminates the 0, which is the leading digit is not 0. So basically, if you are given a number n which is equal to 400, so now 400 is not an exact power of 2, but you could rearrange this to make it 004, which basically means that the number is now 4, which is a power of 2, and you can return true, but the question says that the leading digit should not have a 0. So you should not have a 0 at the start. Now let us see some scenarios when we are going to get true and when we are going to get false. In this case, you will have to get a false, because the only reordering possible for 400 is 400 itself. If we try to reorder it, it will start with 0, then 40 or 004, which is not valid, right? Alright, when the number n is equal to, let us say 64, then we can reorder it to make the original number only, which is 64, which is a power of 2. It is 2 to the power 6. So we need to return true. What about when n is equal to 46? We can reorder 46 to make it 64, and this is again an exact power of 2, so we again need to return true. But what if the number is, let us say 12? If the value of n is 12, we can reorder to make it 12 or 21. Both are not powers of 2, so we need to return false. Now there are many ways to solve the problem, but we are going to understand one of the easiest way. The thing is, you don't need to overcomplicate a problem. For example, you might think that, okay, if the given value of n is equal to 4, 6, 7, 8, then we don't know that we can rearrange this number to make it a power of 2. So one of the possible solution is you try recursion and backtracking for permutation. That is, you try to create all different orderings of this number and try to see that is the created order a power of 2 or not. That can be a way to solve the problem, right? So what basically we can do is we can start our number with a 4, and then we can put a 6, and then we can put a 7, and then we can put a 8. That's one order. We can again start with 4, 6, but then we can rearrange 8 and 7, or 7 and 8. That's another number, right? Or I could say after 4 I would put a 7, then I would put a 6, then I would put a 8. Basically, I will try it with 4 first, and I will put the first digit as 4, then I will try with the second digit as 6, the third digit as 7, the fourth digit as 8. Then I will try different combinations. I will make the 8 as the third digit, I will make the 7 as the last digit, then I will try with 7 as my second digit. This way we can just create lots of different permutations or reordering of our number 4, 6, 7, 8, and then we need to find out is the new number which is created a power of 2 or not. And now we can find it easily. We have already solved the power of 2 problem yesterday, that how to find a number which is a power of 2 or not. You can find the link of that video at the I link. But let's not focus on this, because this will be a very hard way to solve it. If you see the constraints, the given value of n can be 10 is to power 9. So the number can be very large. It can be 9, 8, 7, 6, 5, 4, 3, 2, 1. If you try to create all the different permutations of this number, then this will definitely give you time limit exceeded error, right? Because if we try with a smaller number 4, 6, 7, 8, then we have 4 digits, right? At the first place we can put 4 numbers, at the second place we can put 3 numbers, at the third place we can put 2 numbers, at the final place we can put 1 number. This will be a total 24 different orders or 24 different numbers which are possible from 4, 6, 7, 8. So just with 4 digits we have 24 different possibilities. With 9 digits we will have lots of different possibilities. So we basically need to think about a different way. Now if you try to think about this, that what is the power of 2? The power of 2's are, we have 1, then 2, then 4, then 8, then 16, then 32, then 64, 128, and this is going to continue, right? Now this is 2 is to power 0, then 2 is to power 1, 2, 3, 4, 5, 6, 7, right? If you try to continue creating numbers, you will find that 2 is to power 30, and then we have 2 is to power 31, right? 2 is to power 30 is fine, but when we talk about 2 is to power 31, this will be more than 10 is to power 9. It means that whatever input is given to us, if you want that input to be a power of 2, that power of 2 will be within the range of 2 is to power 30, right? It can either be 2 is to power 0, 1, 2 up to 30. It will never be 2 is to power 31 because our original number n is within the range of 10 is to power 9. So if you try to rearrange that number, you cannot create a number which is greater than 10 is to power 9, right? But 2 is to power 31 is more than 10 is to power 9. So from here, what you need to understand is whatever input is given to us, we can only reorder that input to be a power of 2 within this range. Either it can be 2 is to power 0, 2 is to power 1, up to 2 is to power 30. So from here, what you will understand that you have just a limited set of numbers with which you need to compare your original number. That is, if you have 4, 6, 7, 8. I don't know if this 4, 6, 7, 8 can be a power of 2 by rearranging or not. So first thing is we will find all the rearrangements, right? All the reorderings. Now, even if we have all the reorderings, I will have to check each of my number that is this a power of 2 or not. Now, just for a 4-digit number, I have 24 different numbers. So I have to do my checking for 24 times. For bigger numbers, the number of permutations is going to be too large. But here, if you will notice, we have just 30 or 31 different powers of 2. And what we can do is, we can actually try to see that if I could rearrange my number in such a way that these numbers can actually become power of 2 up to the range of 30. But still, we need to create all the different orderings of our original given number n. Now here is the problem. I don't want to create all the orderings because that will definitely be time limit exceeded error. But what you can really understand from order is, when we say ordering, we actually rearrange the number in different ways, right? But the thing is, we don't really want to rearrange the numbers. We don't really want that number which is rearranged to form a power of 2. We just want to know that can this be rearranged to form a power of 2 or not. So one of the thing which we can do is, let me show you. If the given value of n is, let us say, 218, can this be rearranged to form a power of 2? Yes, it is 128, right? Now, this basically means that we are comparing this with 2 is to power 7, which is 128 here, right? We have just 30 or 31 different powers of 2 with which we need to compare our numbers. What we can do is we can store these power of 2 in sorted order, because the thing is we just need to rearrange or reorder our numbers, right? If we talk about 218 can be sorted to form 128, right? Or if I talk about 125, can this be a power of 2? Yes, this can be rearranged to form 512, which is actually 2 is to power 9, right? But what you will have to understand here is, if this is my original number, I need to reorder it. If I just sort this number and make it 128, if this is my original number, if I sort this number, this will be 125 only. Can I give an answer as true or not? Now, how can you give an answer as true? If I could find out that this number can be rearranged to form a power of 2, what I can basically do is, when I will store my power of 2s, I will store these numbers in sorted order. For example, if I store 128, I will have 128 as sorted, which will be 128 only. But when we will store 512, we are actually going to store 125, which is sorted. So now, if this is my original number, if I sort it, it is 125. If this is my original number, if I sort it, it is 128. 128 is in the list, right? So from here, what I can understand is I can actually reorder this in such a way that this is surely going to be a power of 2. I can reorder 125 in such a way that it can be a power of 2, because I have a number which is equal to 125, which got created after sorting the numbers or sorting the digits of power of 2, right? So we just need to store these different power of 2s in sorted order, sort our own number and check that do we have this sorted number in the list or not. Now let's try to do this in a very optimized way. And if you have a doubt that why are we using sorting if the number is too large, see, the thing is number is too large, right? It is 10 to the power 9, which is 9 number of zeros. So if I write 9 number of zeros here, then if you have a doubt that I am sorting these many numbers, so no, I'm not doing this. I am sorting the digits, right? So if the given number is this one, and if I try to sort it, it will be something like, it will start with 3, then it will be 4, then it will be 5, then it will be 5, 6, 7, 8, right? Basically, I just need to sort a number which is 7 or 8 or 9 or 10 digits long. So this is a constant time sorting, right? Because we just have 10 different data to sort. Now let's start working and let's start creating our power of 2s. So what we can do is we can say for I in the range of up to 31, because we just need to create the power of 2s till 30. I need to create the power of 2. So firstly, the first power of 2 is equal to 1, right? Which is 2 is to power 0. Now I need to store these powers. So let me store this in a set. And the reason of storing these in a set is I want to search in a constant time. So I can store this in a set. I can actually store this in a list as well, because the number of data I will store is constant only. But let's do it in a set, which is a much more optimized way. Now I can say that powers dot add first, right? But what I actually need to do is I need to sort the digits of my powers, because later on what I will do is I will say first is equal to first multiplied by 2. So that next time 1 multiplied by 2, which is 1, 2 will be stored. Then next time 2 multiplied by 2, which is 4 will be stored. Then next time 4 multiplied by 2, which is 8 will be stored, right? Basically, I want to store the power of 2's, but I want to sort them based on the digits. So I will first convert them into a string. Once I convert it into a string, I can use a sorted method or sorted function to sort it. And since we can only store hashable data in a set, we need to convert it back to a data structure which is hashable. So we can use a string or a tuple. So let me actually convert this back, which is right now a list. I can convert it back to a string. So dot join function or dot join method can be used to convert it back to a string. So basically what I did is I first converted my digit or my power of 2 into a string, then sorted it and then converted it back to a string. Now I have stored all the power of 2's. Now what I can do is I need to perform the same operation with my digit, with my given number. So n will be equal to, first let me convert my n to a string, then I can sort my n, which is sorted of string, and then I can again convert it back to a string. So I can say dot join. Now if this n is in the powers, then for sure I can rearrange the n to form a power of 2, right? So I can directly say return n in powers. If this is true, we will return true. If this is false, we will return false. So now we don't need to do anything. I can say, let's try to submit this, and this is going to pass all the test cases, and this is actually a very efficient solution. You can see the runtime is really good. The memory used is really good. We are not even using a lot of memory. So we have solved the problem in a very, very efficient manner. So guys, I have tried to explain you, and I think I have over explained a lot of concepts, and the reason is I want you to understand it in depth, that do not try to overcomplicate a problem. If you can solve it using maths, you can solve it using some algorithms. So guys, that's it for this video. If this video helps you to understand the problem, and more than the problem, if this video helps you to understand the intuition behind the problem and intuition behind the solution, then make sure that you are hitting that like button. And if you are not subscribed to my channel, then make sure that you subscribe to the channel as well. I am aiming for 15 subscribers from this video, so make sure that you do subscribe, and 30 likes. So guys, that's my aim for this video. So that's it for now. I will see you guys in next video. I want to see you guys in the next video. Thank you for watching this one.